we didn't say we didn't need nuclear. We say this is a very interesting topic, and we have technology and competence from the oil and gas industry, and this is definitely something that we should investigate further without throwing it away.
Just because the facts are A, if the narrative is B and everyone believes the narrative, then B is what matters. But it's our job in our industry to speak up proudly, soberly, and to engage people in this dialogue. Those 2.5 billion people that are in energy poverty, they need us.
America cannot meet this threat alone.
If there is a single country,
Of course, the world cannot meet it without America.
that is willing to
We're going to need you, the next generation, to finish the
overhaul
job.
nuclear regulation,
We need scientists to design new fuels.
focus on net public
We need
benefit
engineers to invent new technologies. We need
over absurd levels of radiation protection,
entrepreneurs to sell those
then
technologies.
we will march towards this.
We need workers to operate assembly lines that hum with high-tech,
We
zero-carbon
have
components.
unlimited prosperity for all humans.
We need diplomats and businessmen and women and Peace Corps volunteers to help developing nations skip past the dirty phase of development and transition to sustainable sources of energy. In other words, we need you.
Okay, welcome to another episode of the Fire to Fission podcast, where we talk about energy-dense fuels and how they can better human lives. I'm joined today by Martin Hjelmeland. He's a postdoc researcher in Norway at the Norwegian University of Science and Technology. Martin, stoked to talk to you today, man. This is going to be a fun conversation.
Yeah, likewise.
Yeah. Before we get into kind of your current work and how we got connected, let's give the audience a little bit of perspective and hear a little bit about you.
Yeah.
What's your background, man?
Okay, so I'm a 33-year-old man living in Stavanger in Norway, which is called the oil capital of Norway, even though we're trying to rebrand to energy capital. Before that, I grew up on the countryside in Norway. So if you've seen those beautiful pictures of the fjords in Norway, that's basically where I grew up, working at the hydropower company at the summer job, as well as the aluminum smelter factory as well. So after I started going to college or anything at the University of in Trondheim, Norwegian University of Science and Technology, as you said, where I studied energy and environmental engineering. Like every young kid wanted to save the world, so that was the best option I could find to do that. Did my MS and eventually a PhD within the field of hydropower scheduling. So Norway, 90% of the electricity comes from hydropower, so it's sort of a big thing over here.
Yeah.
Yeah.
I'm jealous growing up in the countryside in Norway. I mean, just phenomenal photos, rugged landscape.
It is. Oh, it was a small farm, so we had sheep and chickens and rabbits, and it was fun growing up on the countryside. It was.
Yeah. Were you, I'll say, energy literate growing up? Like going to school? I mean, was it obvious that Norway was a big energy country? And
I would say, and it was also like working at the summer job at the hydropower company, and next day driving to the aluminum smelter, utilizing that electricity to produce aluminum. You sort of working with the elements and seeing where stuffs are made. And Norway is also large in oil and gas, and my father was working within the oil and gas industry, supplying supply vessels to the oil and gas industry. So energy was always close in mind. But I have to say it's perhaps within the last years more going into the nuclear field that I've gotten much more respect of the oil and gas that we have. Before I was a young naive man who wanted to save the world with renewables, and then started to unravel, and you understand that 80% of the world's energy actually comes from fossil fuels, and it has given us this enormous wealth and opportunity to develop society and civilization that has never been possible without it. So I would say I'm on a continuous learning process within this energy sphere, I would say, yeah.
Yeah, I think a lot of people that step into the space have a similar revelation along the way. They're like, "Wow,
Yeah.
this stuff's really useful." So that the aluminum smelter that you worked at, how big was that? I mean, people talk about nuclear being useful for combined heat and power. Give
Yeah.
us some perspective.
Oh, how large? I would guess it was when it was in full operation, it consumed as much electricity as a large city in Norway of 150,000 people. And like the land it occupied was perhaps like two soccer fields. And you had two halls in the place that I was working, and I think it was 200 ovens in each hall with an operating temperature at 950 degrees. So you walk inside these halls in the middle of the summer, and sometimes it got so hot that we like had to shower mid-work we were just like soaked.
Just to cool off.
Yeah. So yeah.
Wow. So certainly an application that, yeah, nuclear could come in and just use a heat
Yeah.
source. So
Yeah, because there were no utilization of that heat for any other purposes. So yeah.
talk to us about hydropower scheduling. What is
Yeah.
hydropower scheduling?
Yeah. It's the process of like finding out when you should utilize your hydropower. So most simple case, you have one reservoir and you have one hydropower plant, and the reservoir, you get rain inflow to the reservoir. You're not exactly sure how much it's going to rain, but you know that, okay, in May, typically there's a snow smelting that gets a lot of inflow to your reservoir. So you want to make sure that you're fairly low in your reservoir by that, so you can make room for all that water coming in. And you would like to try to optimize the revenue of your plant. You would try to use electricity at times when the electricity prices are high. Because when the electricity prices are high, that's when society has most demand for your research electricity. But since you don't know how much inflow you're going to get to the reservoir or what the future electricity prices are going to be, you do some optimization under uncertainty, or stochastic optimization, trying to figure out when it is optimal for you to dispatch your hydropower. So just to put some complexity into it, say that you have from one week to the other, you might have a lot of inflow or you might have less inflow. So you have two outcomes. And if you trying to optimize for entire years, you have almost two power to the 52 different outcomes of inflow into your reservoir. So it's a very complex and difficult problem to solve, but there are a lot of like these algorithms and tools that are used to solving this problem for when you should utilize your electricity. And I even had during my PhD the pleasure or honor of going to Georgia Tech in Atlanta, where they have a large group or environment there working on these stochastic optimization algorithms. So we went there, learned a lot of stuff, and we applied that to some of the hydropower scheduling difficulties. Because one of the difficult thing is how you should value the water in your reservoir. Because the water is for free, it comes from nature, but you have this opportunity cost. So if you choose to produce today, you can get X amount of revenue, but next week or the month after or next year, the electricity prices will be much higher. You should save your water to produce in those time periods. So this basically the entire task of hydropower scheduling is to figure out what is the marginal cost or alternative cost of your water for you to decide when you should use it. So yeah.
Do you think that system is set up efficiently? And I'll characterize it that way and describe, in the States, a lot of people are installing energy storage systems with batteries. And the idea is you use them to back up the grid when you need them, but sometimes it doesn't always back up the grid because people might do just that. They might wait. If you only have so many hours of storage, then you may not back up the grid exactly when the grid needs it, but rather let the
Yeah.
price go up a little bit higher.
Yeah, totally agree. And because there is a slight difference in what we now conceive of battery storage and the long-term duration hydropower storage, because we fill up our reservoirs in Norway in the spring and summer, we save it for winter, and then during winter we deplete. So we see, for instance, that if you see the maximum and minimum limit of our hydropower reservoirs, we're never touching the lower limit. So we don't dare to empty our reservoirs completely because we are not sure how much is going to inflow to our reservoirs going to come in the next days.
Yeah.
So we have this very strict way of operating them, because if we go empty and there is more demand for electricity, there is nothing left. So by utilizing this stochastic optimization, we can see that, okay, if there's no more inflow to our reservoirs, we need to have at least a certain amount of water left in our reservoirs. And that is typically when the electricity prices can become very high in the spring before the snows melt. If you're very low on our reservoirs, it doesn't look like the snow melt is going to come in the next week or two, we've seen electricity prices skyrocketed in the past. So,
Wow. And I mean, you guys are very lucky with the amount of hydro that you have
yeah.
in Norway. It's just a consequence or artifact of your landscape. So, do you have a number for that, or how much that is, and or a comparison
I
for it?
think we generate in a normal year around 135 terawatt hours of electricity. But the thing is, it's not a stable supply of inflow or rain. So some years it can be 30, 40 terawatt hours less, or in some years it can be 30, 40 terawatt hours more. So that's also why we need to consider that, okay, maybe this year it won't be enough inflow to our reservoir, so we need to be able to make sure that we're able to have enough electricity, given that this will be a dry year where there is not much inflow to the reservoirs.
Okay, so 100 terawatt hours per year, but how much storage do you have at any given
So
time?
complete storage, it's around 80 terawatt hours. So I think I've mentioned this before to someone else, that if you want to have a 100% renewable power system, like we do here in Norway, you should just follow our recipe. And our recipe is
It works. It works great.
it works. It works, but it requires that you have an enormous amount of storage. So we have 87 terawatt hours of storage capacity, and we yearly produce 5. So for all the renewable generation, we have 65% of that backed up by long-term duration storage. So if you don't have high mountains and deep fjords, it's very hard to reconstruct that type of environment to get that type of or amount of long-term duration storage. So yeah.
Gotcha.
Yeah.
I mean, if we were to do this with batteries, do you have a comparison for how much it would take, or how many batteries it would take for an equivalent?
No. But the thing is, with batteries, you also have a much higher capacity, so you can drain them much faster. Because the hydropower battery in Norway is a very slow battery. It takes a lot of time to fill up, and it takes a long time to deplete. So if you were to substitute the amount of energy storage by batteries, you would also have much more flexibility in the installed capacity of how fast you can drain and power them up. Yeah.
Okay, so I mean, you studied hydropower, fascinated with energy, dad in oil and gas. Why nuclear? How'd you get introduced?
Oh, it was, as I said, I studied 8 years at the university on energy and environmental engineering, and I never learned anything about nuclear.
Isn't that weird? Like I went to CU. We studied energy and the environment, and I mean, we talked about it quite a bit, but it was always kind of at the top of the list, and just oh yeah, no, nuclear exists.
yeah, yeah. So I think this in the back mind. I had a friend approach me. He was working at a financial firm, looking into some nuclear investments. And since I've gone to school for so many years and learned about energy, he was probably thinking that I knew a lot about nuclear. So, but I didn't, and then I was a bit frustrated that I didn't know anything, and I started reading. And came over this YouTube channels by like Gordon McDowell, talks by Michael Schellenberger. But I think the lecture or the presentation that gave me the thought that, oh my God, why aren't we doing more of this? This was a lecture by Geraldine Thomas. She was a professor at, I can't remember, but a UK university. And she had this talk on radiation health risk from nuclear accidents, facts and fantasies, where she just put out all the facts that she could provide. And from that, it was just like, okay, humanity has done a huge mistake of being misinterpreted how dangerous nuclear energy actually is.
Yeah.
So, and also considering that, I think she mentioned it in somewhere else, that before working on this Chernobyl tissue bank that she was head of, she was anti-nuclear. So when she started looking at their evidence herself, she was just like, okay, we have got it all wrong. So I think that just ignited the spark, and reading the reports from Joint Research Councils of European Commission on nuclear, and this UN report on sustainability from different energy technologies. And yeah, like the more I read, the more I've had issues with us not going any further. But I've also managed to get a bigger understanding of all the hurdles and issues that's been there along the way that has resulted in the way that we're here now. So yeah.
Got it. Yeah, Geraldine Thomas's work is phenomenal.
Yeah.
If anyone's unclear of it, like you mentioned briefly, she's the head of the Chernobyl tissue bank, right? That's the project that they've actually got the samples from the liquidators or the people, the humans that were at Chernobyl, and they took tissue samples and tracked them across decades. And it's one of the best data sets that we have to demonstrate exposure to radiation. So have you stayed in academia or worked in consulting or?
Yeah, so to go back, after I finished my PhD, I started working at a hydropower company. Worked there for a couple of years, started as a consultant. And during my time as a consultant, I came across this nuclear adventure, to say this, to frame it like that. And I was lucky that I had a boss that allowed me to go down to 50% workload, so that I could pursue any opportunities, or just basically just spend more time on learning more about nuclear energy. So during that time, I contacted my old professor at my university. He was my supervisor during my PhD, and initially I was a bit skeptical about starting a project related to nuclear energy, because nuclear energy within academia has been very hard for some reason. I think I was super lucky because his father was actually one of the guys working on a research reactor, constructing research reactors here in Norway. So he was, even though he was a bit skeptical, he was open, and he had his history with nuclear energy. So after a couple of months, we got in contact again, and we started on creating a postdoctoral where we're going to investigate. So we called the project the Nuclear Energy's Role in a Renewable Energy System. So I think it was important that we had the word renewables in there in order to sell it and get funding.
Everyone's got to market themselves, right? Yeah.
Yeah. No, but so that's the project I'm working on now. Since I'm not a nuclear physicist or a nuclear engineer, my main qualities or competences is with like optimization and energy system modeling.
Which is probably more relevant when you're thinking about the energy system as a whole, deciding which generation resource you want to use, right?
Yeah, yeah, definitely. Because there's been within research a couple of decades, there's been conducted so much research on this 100% renewable things. So how can we get as much renewable into the system as possible? So the thing we want to do with our project is to see, okay, what if we lower the bar to low carbon technologies? As what role nuclear power can have within this system. We also come across like energy system modeling is. I don't want to be negative against my own group, but I think it's more like a soft science, to be honest. It's you can do whatever you want basically, and whatever assumptions that you put in, you can get out what you want, and you can simplify the problem. So you can have this copper plate theory that there is basically no grid in your system, or you can combine the hydropower system of Norway into one reservoir and one power station that is super flexible in the model, which makes it a lot easier to incorporate renewable energies. And so it's quite the field to be in, and I think
I like you had this characterization in our notes from ahead of time. It was models are used for decision support, not as definitive solutions.
Yeah.
I thought that was really good.
Yeah, because as I said, it's completely impossible to model the physical system exactly. So there will always be some assumptions. Some models do these assumptions, some models do those assumptions. You need to be able to understand what those assumptions are and how they apply to the results that you're going to interpret. But also, the model is most likely minimizing the total system cost. So if you're minimizing the total system cost from a European div, that might not provide the best power system for the Nordics or in Portugal or whatever, because it has this dictator sort of way that just is able to build and construct wherever he wants in a least cost way. But there are other metrics that should be included when planning an energy system, like how much of these resources do I have within my own borders? What is the value creation or technology needed for this source? And we've seen it in the past with the oil crisis in '74, how France just turned on this Messner plan and went all in on being less dependent on foreign oil and gas.
So you love, or you are falling in love with nuclear. You've studied it more and more. Maybe that's a mischaracterization. Norway doesn't have any nuclear power, right? Give us some perspective on Norwegian's nuclear history.
No, that's true. And currently there are no. We had some research reactors operating in Norway. Norway was actually the 6th country in the world that got a research reactor. So in the early days, we created an Institute for Nuclear Energy, it was called. So the idea was it was the Labour Party in Norway that wanted to reconstruct the country after Second World War, and they saw nuclear energy as this was something that it would be the world in the future will be divided by those countries that harness nuclear energy and those who do not. So it was a large push for nuclear energy back in the days, and this institute was founded in 1940, and 3 years later they had built the first research reactors. So in these times where nuclear power plants constructions had taken a lot of time, they were able to do it much faster in the future, even though it was small scale research reactors.
Did you say it was 1948?
Yes. So the institute was founded in 1948, and the first reactor was operating in 1951.
Do you know what type of reactor it was and how big it was?
It was a heavy water reactor. So I think we went down similar paths as the Canadians with their can-do design, where we, by utilizing heavy water, we could use natural uranium in the reactors. And also, I'm not sure if you're familiar with this story, this war story in Norway, where the Germans were making heavy waters by utilizing hydropower electricity during the war.
That's right.
Yeah.
Yeah. I was
So,
aware of that.
yeah.
Back in the back of my brain somewhere. Yeah.
Yeah, so I think that was also one of the reasons that heavy water was the path that was chosen back then.
Yeah.
And so back in those days, it was very high optimism for nuclear in Norway. A couple of years later, in 1950, it was funding a new, larger 5 megawatt boiling water reactor in Halden in Norway. So that was also finished 3 years after, and they even used, it wasn't used for production, but they used steam from that reactor for a paper factory. So they also had some steam or heat utilization back in the days. And
25 megawatt reactor built in 3 years.
Yeah.
In 95, before computers, before, right? I like to highlight those facts to compare to like what we are conceptualizing to do now, like this is a micro reactor that can be built from scratch essentially. Like this technology is not that hard.
And the thing is, after the war, there weren't much collaboration on nuclear energy between the different countries. So this was all 100% made by Norwegian companies and Norwegian competence. So it wasn't something, a large project like the Manhattan Project or similar. This was a small country being able to do this. But it should be said that for constructing the first reactor, they were funded 5 times as much as the entire R&D project in Norway. So it was a large project for.
They had the resources, the money behind it.
Yeah. And it was. They even wanted to. There was a group of shipping companies that wanted to make nuclear powered ships, and we were going to sell power plants to the Middle East and Europe, and it was really the heydays of the atomic age back then. But
so what happened? Why isn't Norway a nuclear exporting country?
Well, the 70s came to Norway as well. Around the world, the light water reactors started to dominate, so a majority of the world went a bit different path, and we built more hydropower in Norway than we thought was economically available. But basically what we did some hydropower investments back then that weren't economically viable. We did it anyway. And by doing that, we now, years later, are benefiting from such investments that was done in the past. But if you would have done the net present value calculations back then, it wouldn't have made sense. And
for
you also
hydropower?
Say what?
For hydropower?
For hydropower, yeah.
Interesting. You mean it wasn't as economic as building nuclear power plants or as building natural gas power plants?
No, I think there were a regulator in Norway at that time. They had their own thermal divisions. They went to Sweden, to Germany, able to learn how to regulate a thermal power plant or a nuclear power plant. So there was a lot of activity going on within Norway, but it was never. In the 70s, a parliament vote came that we're not going to pursue nuclear energy. I'm not sure exactly how the process went, but basically they just lowered the investment criteria for the internal rate of return of the hydropower plants in order just to construct them. So if the criteria was 5%, they lowered it to 2% in order to be viable. So
got it.
Yeah, that was it. And also in 1969, we had an American company, Phillips Petroleum, digging a lot of holes outside of here, and they came across the Ekofisk field, and that was the start of the oil and gas adventure in Norway. So a lot of the technology and industry was pivoting towards supplying to the coming oil and gas industry. So it was we had more hydropower than we thought, and the oil and gas adventure started, and that was the slowing down of nuclear research in Norway. But the Institute of Nuclear Energy, they changed name to Institute for Energy Technology and started working on hydrogen and solar and wind as well. So they diversified. But I think what is interesting to mention is that the nuclear technology that was and competence that was created by building those nuclear research reactors here in Norway were highly utilized within the oil and gas industry that we came. So, because it was a bit concerned, it was a meeting between some American representatives and the Norwegian industry minister and his team, where the Americans were a bit concerned that do you Norwegians know about oil and gas, and how are you able to be a supplier for the oil and gas industry? And then they could straighten up in their chest and say that we have built nuclear reactors. How difficult can it be to dig some holes in the ground? So that's sort of they had the courage and believe in themselves that they could able to supply to this industry, and certainly they've done that.
It's entertaining because the roles are kind of reversed now, right? Like there's maybe some more.
That's what we're gonna discuss in this ONS conference here in Norway this fall.
Yeah.
Where we're gonna. I've been so lucky to have you come and sit on a panel where we're gonna discuss from oil and gas to nuclear. Where we're gonna discuss what type of technology and competence the oil and gas industry has to apply within the nuclear.
So you mentioned the ONS conference. What is that?
So they've been an oil and gas conference, large. I think they've have some exhibitors, and last time there was 60,000 visitors for the conference. But now they've pivoted to include all energy sources. So there will be talks about wind power, solar power, nuclear energy as well. But historically, it's been a meeting place for the oil and gas industry to come together and have a large exhibition here.
And it's not a small conference, right?
No, it's okay. So the capital of the city of Stavanger, I think it's 100,000 people living here, and the conference has 60,000 people visiting. So it's town is turned upside down during this conference.
Yeah.
But that's what we're going to discuss there. But just to show or tell a little about what the competence from the nuclear research in Norway was applied to the oil and gas industry. I have some examples I would like to share.
Yeah, fire away.
So, in order to get more oil and gas out from the wells, you can do water injection and CO2 injections into the well. And knowing where to inject those water and CO2, it's important to know how the reservoir flows in your reservoir. And this is where the researcher from the Nuclear Energy Institute came up with the idea by injecting radioisotopes into the well and then be able to map how the streams or the flow into the reservoir. And by doing this, they were able to pinpoint what are good locations for injections into the well. So the Ekofisk, the field that I mentioned, it's a huge field. I don't recall how many barrels of oil. But after a couple of years of producing, it has reduced its production by half. And Phillips Petroleum were a bit concerned about since there was 70% of the resources left in the well. So that's why they came on, used this tracer technology, found out where to inject, and this field is still producing the day to day. So it's been quite the remarkable feat to.
That's a pretty good recovery factor. I mean,
Yes.
in shale
It's
wells in North
yeah.
America, like,
Yeah.
if we have a 6% recovery factor, then people consider it kind of a home run. And that's so
Yeah.
what percentage of oil or gas are you getting out relative to how much was in place? And you just said they
Oh.
had a 30% already, and they're like, we got to get more out, and now they're still producing more. So
Well, I would just do that. I don't know the number, but I would estimate from the graph I've seen around the production. So if they were 30% back then, I would say they're perhaps 30% less left in the well now, or 10 in that
yeah,
range. Yeah. And but also the investments in oil and gas. In the early days, there was a lot of you needed the separation of your oil and gas and water and CO2 and methane coming up from the reservoir needed to be separated onshore. So you needed to construct these large oil and gas platforms with a lot of process engineering equipment on them and drag them onshore. But since the research here in Norway and research reactors have been going on boiling water reactors, it was very important to know how this multi-phase flow was, this water and steam was operating within the reactor. So they built very good simulation softwares for simulating this multi-phase flow. And by utilizing this software within the oil and gas industry, they could enable them to do the separation on land. So no more need for these expensive oil and gas rigs. You can do more separation on land. This was also basically the foundation for the subsea industry in Norway, that we had this software. So now I think Schlumberger or SLB, they eventually ended up buying this Olga software. I'm not sure if you've heard about it or
I haven't. No,
no.
it's new to me.
Yeah, apparently it has a 90% market share, and it's been used all around the world, and extremely. I think it was coined the best innovation in Norway a couple of years ago. So quite the feat that we should be proud about. And also other stuff, you have corrosion technology that this institute provided to the oil and gas industry. This control room technology where you had this human machines going on. For instance, in the 3 Mile accident, it was read that if the control room operators didn't do anything, it wouldn't have been the problem that it was. So they were given a lot of blinking red dots in their operating room, and they didn't know exactly what information was the most relevant. So after this accident, it was a lot of focus in Norway and around the world on how to give the operators the information that they need when they need it. So this has been a large research topic here in Norway about this human-machine interface thing. And this has been utilized now in oil and gas installations around the world as well. So yeah, a lot of good stuff has come out of those early nuclear research days. But as you mentioned, there's still no commercial nuclear power plants operating in Norway, even though our neighbors in Sweden have a couple, and they have plans to build a lot more.
Yeah. So is that changing? And you mentioned that the sentiment in the 70s wasn't super popular about nuclear, but what's it like now in Norway?
So I think the sentiment in the 70s was more the industry and elite, so to say it and frame it in that way, that wanted nuclear energy and saw the benefit of it, but the general public did not. But now I think we've seen a complete switch of that in Norway, where according to a recent poll, nuclear energy is more pop than hydropower in Norway. So that is quite something. And I think one of the reasons behind this is that we've had some wind power onshore developments in Norway in the last decade. Norway is there's been quite a dispersed country where people lives in every fjord and everywhere. So if you put up a wind turbine, there will be people living next by. And these people have been demonstrating and protesting. I think currently there are no onshore wind power plants in Norway. And if you
I didn't know
combine
that. Really,
yeah,
I thought in the north there were some, but there's not.
not onshore.
Okay.
They're large offshore plants or plants. But if you combine this opposition against onshore wind power with the high electricity prices that we've had the last couple of years, people have been looking for questions, isn't there an alternative? And I think with all that sustainability reports coming out about nuclear energy and the environmentalization either toning down their negative talk about nuclear energy and also being, we've seen a complete shift. So now it's ordinary people in Norway. Whenever I go to a social location and mention what I do, we talk about nuclear the rest of the day. And so it's been a complete turnover with over 50 of the municipalities in Norway out of 357 now want to investigate whether nuclear energy is an option for their municipality. But we're still struggling with the members of parliament or the high-ranking politicians that are still focusing on only wanting to build float offshore wind or offshore wind. So we recently had a tender on that. So that's the status. The ordinary people are much more in favor, and the politicians in parliament are still skeptical. But we've seen someone turn around, and some political parties have turned around. So it's election year, and we'll see if nuclear will become a large part of that election, as there was in Sweden when they now recently switched the government there.
Yeah.
So yeah.
Yeah, it's interesting. The feedback loop in politics can be very slow sometimes, and sometimes it can be very fast.
Yeah.
And but yeah, I found on this topic in particular, there's a lot of hangover from the mythology of the past, and but it changes, right? We've seen it change, so it can change in Norway.
Yeah, true. Look, the thing is, we even had in a couple of years, 2000, it was a U.S. Geological Survey that found vast amounts of thorium here in Norway. So we had this, it was called the thoriums of 2000, where there were a lot of discussion about Norway going into nuclear energy by utilizing thorium. So there were even plants back then, industrial representatives that wanted to build 2 research reactors in the eastern part of Norway. That is now 15 terawatt hour of deficit of electric power. So if we 16 years ago would have started construction of those 2 plants, it might be a complete change in the electric deficit over there. Back then, the current oil and energy minister, it was ordered a report that was developed by a group of international researchers of how the opportunity for thorium was in Norway. And when this report was presented to the minister, she received it. And without even opening it, she said nuclear energy will not be a thing in Norway as long as we have the current government. So
what's the point of the report?
Yeah.
Why have reports if you're not going to read them, right?
Yeah, I know. And she got a lot of pushback because she said that renewables, wind and solar, would be more than enough. And even a professor back then said that was deceiving the public, stating that there's no need for nuclear, as renewable is enough. So
wow,
it's been quite. And one of the ironic thing is that she is now currently the head of Renewables Norway, an interest organization for renewables in Norway. And they have done a lot of work in opposition against nuclear energy in Norway. So it's it's strange.
So strange. Yeah. What was the Rystad Energy report?
Yeah, we we stirred things up a bit in December. So me and a
Just
colleague.
last December, yeah, in 2023, right?
Yeah, last December. So me and a colleague, Jonas Nøland, since we had the research project that we're working on together, we were approached to create a chapter in a book about nuclear in Norway. So we created a book chapter or a report that was titled "Nuclear in Norway?" where we discussed like the benefits and saw how nuclear has been used to decarbonization in the past, how mapping technology, and that we have a large oil and gas company, oil and gas sector that can utilize their competence technology, and sort of just like trying to get some more facts and just start to create a debate about the question, about the subject. And what came to be is that on the day that our report was published, Rystad Energy also published a report that was titled "Nuclear in Norway," and that was commissioned by Renewables Norway, among others. Yeah.
Okay.
And to answer this question. And we heard rumors that 2 weeks before the presentation of this report that they had, the CEO of Rystad Energy, he has walked around park and telling politicians that in 2 week times there will come a report that will be the nail in the coffin for nuclear in Norway. So just relax. So yeah, we were a bit frustrated about that. So on the day of the report was to be presented, both ours and theirs, we were approached by a newspaper in Norway to get an interview about this, and we gave some comments about the report, that they've used 4% interest rate for offshore wind, they use 7% for nuclear, they have a lot of self citations, and that their power system studies in the report was limited. What they were basically saying that when there's not wind or hydropowers are not no water left, we can just import from our neighbors. So just the solution that everybody does is just everybody imports from their neighbors. What we said in the interview, we called it commission work. They were like bought and paid for. So we were a bit direct and up straight about our opinions about that work. And we were not the only one. Another newspaper, they used a ChatGPT to create a summary of the report that did not include the executive abstract or executive summary of the report, and that gave a completely different answer answer to the report than what was listed in the executive summary. So the headline of one of the newspaper was ChatGPT shreds Rystad's shred of nuclear. So it was quite funny actually, that.
Yeah, I'd been aware of Rystad for some time, and they're perceived as a pretty competent consulting group, right? I mean, they're an energy research firm, and I was just, while we're chatting, I'm looking on their website, and yeah, they've got our expertise spans all components of the energy system and the different paths towards net zero. And they've got oil and gas, power, solar, wind, hydrogen, geothermal, carbon, batteries.
Yep.
So I'm pretty sure they're missing.
Pretty
sure. Key, like, there's one that's producing 10% of the world's power that's not listed there.
That's true. And it's that
seems
was also
biased. They might be biased, right? They've got like their services, their expertise. They may, and not to, this isn't supposed to be just spreading Rystad, but like, it doesn't look like they have nuclear listed on their list of services. So maybe they're just worried that they didn't have the expertise to provide any consulting services for it.
Yeah. This was also one of our critiques, that if Renewables Norway and the other institution that's ordered this report was interested in to get the facts about nuclear, they would have commissioned it to someone who actually are familiar with the technology. But there's no doubt that Rystad Energy has done a lot of good work, basically mainly within the oil and gas industry. But yeah, as you as well pointed out, I'm also very skeptical about their knowledge about nuclear industry and some motives there as well. But this was basically just the start of the story, because a couple of days later, the rector at our university came out with a chronicle stating that she took absence from the language that we used in the report. And I felt, maybe I've stepped a bit over, and I agreed that I could have did another wording that would get the same message out there. But the day after, I think it was around 5 chronicles in different newspapers in Norway came in support and said that the rector at NTNU has stepped over the line. This was coming from even board members at the university and other high-ranking professors around Norway, saying that this can be seen as an attempt to limit the free academic of speech. So that was quite touching, and I think it went a day or two after. It was revealed in another newspaper that a high-ranking member of one of the institutions that ordered this report by Rystad have sent a message to our rector and said that I look forward to you publicly commenting this. Otherwise, we will have to call out the leadership. So it was basically telling her that she had to go out and reprimand our behavior. And after that, all hell broke loose, and it was starting to come all over the news. Yeah.
So who called them out?
Who called out who?
Yeah, who said that? I look forward to your public comments.
So that was a high-ranking member of one of the institutions that ordered this report from Rystad Energy.
Okay.
So he was upset about the way that we characterized the report he had ordered.
Gotcha.
Yeah. So it was quite the experience living through that, and I didn't felt I didn't do anything wrong. We just I've put my wording in a bit off, and suddenly we had a lot of friends calling and a lot of newspaper reports, journalists trying to be in contact. So it was a period where I didn't were as efficient in my work as I would have required myself to be, and even a reporter started digging if I was affiliated with any nuclear groups and where I've gotten funding to travel to conferences and etc. It eventually became a bit stressful and quite the experience to have with you.
Yeah, absolutely. Just to kind of recharacterize it, like this Rystad Energy report came out and said, you guys don't need nuclear. You guys were like, no, we absolutely need nuclear. We said assumptions were wrong.
yeah. We didn't say we didn't need nuclear. We say this is a very interesting topic, and we have technology and competence from the oil and gas industry, and this is definitely something that we should investigate further without throwing it away. So we want to seek more knowledge, but so that was our stand, and still is our stance on.
Gotcha.
Yes, and to round up, all over the news, and a week or two later, it was called in an extraordinary board member meeting at our university, and where our rector decided to resign, and so that was the sort of the end of that history.
Why did the rector resign?
Because she had been. It was perceived that she had done the bidding of the industry.
Wow.
So university is should be an institution that is where there should be no head of the university. Like researchers should have their own voice and able to participate in the public debate with their knowledge without there being someone on top deciding what and who should say what. So this academic freedom of speech is a very important thing for a democratic society where you want a researcher to point out issues. So say, for instance, for other controversial issues like we have a lot of salmon farming in Norway, and if people in the industry there were to put pressures on researcher to don't look into how this affects the nature and the sea, it could be very like controversial. And yeah, so we need researchers and people in general to be able to speak their mind without being afraid of getting a reprimand. Yeah.
Okay, so what policy goals might exist in Norway? Where do you think this goes? How do you guys make the necessary changes to potentially build more nuclear?
Well, first of all, I think, as we've been talking a bit about, we've had this renewables where we have been so narrowly focused on building renewables that we have lost way in what was the actual goal that we wanted to obtain. And I think the goal that we want to obtain is that we have reliable energy that is available when society and people needs it, and that we are able to generate enough electricity for the developing countries that are in need for or want to industrialize, and also that we are able to preserve our nature, so don't industrialize our nature that much and conserve that. But we have lost all of this, and the main focus is just like build renewables. So I think we should just take a step back and realize what is our actual goals, and maybe we could change the goals of building renewables to building low carbon electricity instead, where nuclear definitely can play a major role in that. Like we've seen large power systems that have been deeply decarbonized, it's hydropower or nuclear. So reconsidering and thinking about that, I think it would be very important. But our politicians, they have decided on a solution, and they have been, especially here in Norway with the offshore wind, they've been very focused on building that out. But I think, as my father said, the job of a politician should not be to dictate; it should be to facilitate. So facilitate that all solutions that are able to contribute to a goal should be able to do that. Because if you think you can predict what is going to happen in 5, 10, 20 years ahead, you're not very smart, because that is impossible. And no one is able to predict that, and that's why we should have all the options available to provide to that goal, and have the people putting their own money and their own working hours should be able to provide the best solutions to provide to that goal. Yeah, so that was just some dabbling on that matter.
I like it. I think it's fantastic. Cool.
I can also just mention that, because an illustration of how I think we should consider our energy systems is that in a couple of years there's been a lot of focus on this decentralization. I think it has come largely from like the cryptocurrency world, where decentralization is seen as the best things in sliced bread. But for a modern and industrialized society, you rely on some centralized services, and it's better that there is some centralized services like schools, universities, and hospitals, and also our power grid, which is basically like a natural monopoly. And so I think we should also put some more efforts in trying to strengthen centralized systems in order to be more against or more routes going further. So we see, for instance, a lot of, or just to take an analogy, that myself and others, we like to do some gardening and create some food back at our own place. But when you're not able to water them properly, or the weather is bad for weeks to come, you're not able to grow the crop that you want, it is very nice to be able to go to the store and buy the food that you need. But if everyone starts to produce their own food, and everyone experiences the same weather, and everyone is going to the store trying to buy the same food, it would be much more difficult for the store to plan and schedule for the demand. And also, if you've centralized this, rather than everyone is having their own equipment to grow plants, it would be better to centralize in a material perspective, to centralize this and have this done in a more large scale way, because food and electricity is something that modern society is so completely dependent on, and we should make sure that we have a resilient system of both. So it was probably a long tangent, but
No, I love that analogy. I think it's really helpful. It's fun. It's easy to conceptualize. So,
yeah,
uh, yeah. Martin, this has been great. Why
yeah,
don't you give one more plug for the ONS conference? Where is it? What is it?
yeah,
If people want to be involved, I'm excited for it because, it's an excuse to go to Norway and see part of the landscape and do a little touring while doing some work. So, get people excited about it.
yeah. First of all, as mentioned, it's an energy conference in Stavanger in Norway. And I think it is the 26th to the 29th of August. Is that correct, Mark? Do you have it in your calendar?
Uh, yes, I think so. Yeah,
Yes,
Monday to
yes.
Wednesday or Thursday, the
Yeah,
August, like last week
yeah,
of August. So,
yeah. And it's a huge gathering here in Norway, where there will be discussions about nuclear energy and solar energy and wind energy and oil and gas. And I think even there's been invited representatives from Canada, Sweden, and the UK, and you, Mark, and others from the US are coming to talk about nuclear energy. And on the first day, the 26th, at 7 p.m., we are hosting a panel session where we're going to discuss on the topic of going from oil and gas to nuclear, where we have you. We have two oil and gas companies here in Norway joining the panel and discussing about the technology that they have. And it would be a great experience, I think, to discuss and have some public discussion about this. And I think it could be something that is being very interesting and useful for the oil and gas industry to view. And maybe we can even have a pub. Maybe you can even show it on your Fire to Fission podcast for your audience
yeah,
to view
we'll
as well.
record it and then we
Yeah.
can just post on here. So that'll be great.
Yeah. So if you're not coming, check out the Fire to Fission podcast late August.
We shouldn't have said that. Now, you got to go in person, see it in person if you really want to get it. Right? So, no.
Yeah.
Martin Hjelmeland, I got the name
Yeah.
right. The
Yeah, you got
spelling's
it.
tricky for American Man, I really appreciate this. This has been wonderful. So we'll have to do it again.
Yeah, me too. Wonderful.
All right. Thanks, Martin.
Thank you too.